Okay, so for example 2, we have a similar setup here as the last example. We have a point cloud, we have a sphere made into a volume and points. So we're gonna use the VOP now to do sort of similar thing as last time, but instead of adding and subtracting, we're gonna use multiplying and dividing, and see how that works to modify the position of points. So if we dive into the VOP here and make sure to visualize it so you can see the changes, we have exactly the same setup here, as you can see. But instead of having an add and subtract, we have a multiply and divide. And our vector in this case is a constant with the values of 1, 3, 1. The switch works the same way as here, and we have from position, we pipe that, and we have that pipe to position. So the vector gets from here, we modify it here, and then we output the position and the vector by piping it here. Anyway, so how the multiply works. So multiply is a bit different. Since multiplying something by 1 outputs the same value, we can have to be mindful of that. So you should never multiply anything by 0, unless that's actually what you want. So in a constant here, if you would set that to 0, 0 here, and we said I only want to multiply things in y direction, right? Then if we now switch to this input here and see what this multiply node will do is, it will do this. It will put the x and z values to 0, which we don't want. We only want to multiply the points in y, but we want to keep the points, that is, we want to keep the values in x and z still. So how are we going to do that? We switch it back, and we're going to put the first x value to 1, and the last z value here to 1. This means we will multiply x by 1 and z by 1, but y will be multiplied by 3. So what does this look like? Let's see. So if we've checked the geometry spreadsheet, we can clearly see that all the points are like this. They have a value. And if we now switch it to input 1, we're gonna see this. So all the positions are multiplied in y, but kept the same in x and z. And exactly what we want. So if we check the spreadsheet, we can switch, and we can see only the values in x in y changes. Sorry, which is cool. So as you can see, they get multiplied, so the position get dragged out a bit. Now, if we would divide this, it would have the total opposite effect, right? So if we switch, so if we have the divide here, we have the vector with 1, 3, 1 connected to the second input. And if we switch to the divide input on the switch node, we get this. It flattens it out, but it keeps the point position in x and z, but the y position gets modified. So that's kind of how multiply and divide works. Usually, this is a tip from me, I usually never use the divide stop, because I've heard it's supposed to be slower than the multiply. So if you want to divide something, you can just put a constant, and you can put 0.5 if you want to divide it by 2, or 0.25 if you want to divide it by 4, and I mean 0.1 if you want to divide it by 10. It's kind of simple math like that, but I would stay away from the divide stop if you can, because I've had, when you have millions and millions of points, it's gonna get slower, and divide stop is a little bit slower, and that kind of increments when it's a lot of geometry. So I usually try to tend to use only the multiply and kind of go backwards like that, but yeah. Anyway, yeah, that's for multiply and divide. So now we have subtract, add, multiply and divide. See you guys in the next tutorial. Bye.